Now comes alkenes and alkynes. They are also hydrocarbons, but the bonds and the number of hydrogens surrounding carbon is different. Ethene, which is C2H4, it is also known as ethylene, is an important plant hormone which is involved in promoting the ripening of fruits, for example, bananas. Alkenes and alkynes are also family of hydrocarbons, which I already mentioned. That means they also contain carbon and hydrogens. They also contain double and triple bonds. They are called unsaturated hydrocarbons because they do not contain the maximum number of hydrogen atoms. They can react with hydrogen gas to increase the number of hydrogen atoms, and they can convert to alkanes. We have to always remember that carbon atoms will always have 4 covalent bonds. How do we identify alkenes? Now, alkenes contain one or more carbon-carbon double bonds. What is double bond? It looks like this. So you have 2 bonds between carbon-carbon. And if you try to draw with the ball stick model, it looks like that. And the bond angles between 2 carbons, it is 120 degrees. And the shape is trigonal planar. Ethene, which is C2H4, I have already mentioned that it is an important plant hormone which can be used in ripening of fruits. It accelerates the breakdown of cellulose in plants, which mainly causes flowers to wilt and leaves to fall from trees. Alkynes. This is different than alkene. How do we identify alkyne? It has a triple bond between 2 carbons and the bond angle is 180 degree and it has a linear arrangement between 2 carbons. Let's try to identify which one is alkene and which one is alkyne. Now, alkene has carbon-carbon double bonds, which is compound A, and compound B has carbon-carbon triple bonds, so it is alkyne. This table actually shows some of the alkene, alkyne, and alkane, how to name them. They are kind of similar, it's just the end part is changed. So once we have alkane, only single bonds, the name ends with A-N-E. When we have double bond, the name ends with E-N-E. So 2 carbon ethene. For alkyne, the name ends with Y-N-E, ethine. So going from propane, which is an alkane, no double bonds, to propene, 1 double bond, E-N-E, propyne, where we have a triple bond present. Let's try to name them as according to IUPAC. Compound 1 has a double bond. The rules are same. You have to identify the longest carbon chain and you have to number them starting in a way that the carbon bearing the double or the triple bond comes with the lower numbered carbon. And then obviously we have to point out the branches and the substitutions. So for compound A, we have a 5 carbon chain with the red line and it is an alkene, so name ends with ENE. Similarly for the compound B, it is a 6 chain carbon structure and it has a triple bond, so it should end with YNE. Next step is where do we have the double and the triple bond? And as I mentioned, we have to start numbering the carbon in a way that the carbon starting with the double bond or the triple bond gets the lower number. So for compound A, we are starting from the left hand side where you get the double bond started at number 2 and it's between 2 and 3. So we write 2-pentene. For compound B, we are starting from the right hand side. That way we get carbon number 2 having the triple bond. So 2-hexyne. Next, we have to identify and point out the branching or substitution. For the compound A, we have a substitution at 4. So it is 4-methyl 2-pentene. For compound B, we do not have any substituents, so it is simply 2-hexene. For cycloalkenes, everything remains same. It's just we have to use cyclo before alkenes. And we have to assign the double bond starting from the carbon where the double bond starts. We have to number the carbons from 1. So in this case, if we start numbering the carbon bearing the double bond as 1, the next carbon is 2 and 3. So it has 3, number 3 substitution with methyl. So it is 3-methyl cyclopentene. Let's try to name these alkene and alkynes. This is a cyclic compound. So the first one is cyclohexene because it has 6 carbons. And the second one, we know that we have to start numbering the carbon bearing the double bonds first. So 1, 2, the double bond is between 1, 2, and at number 3 position, we have 2 substitutions, which are methyl. So it is 3,3-dimethyl cyclopentene.